Okay, so we have the last section of this unit. It's been quite the journey, right? Let's go ahead and start solving this thing. Okay, so it says express the interval in set builder notation and graph the interval on a number line. So believe it or not, it's not that bad. Over here we have -9, comma 8, and then we have the inequality symbol. All right, so a quick rundown. You remember these guys, the alligator mouse? And then you also have something like that, same thing, but with an underline. This symbol right here stands for less than. And if you ever forget, you can imagine you can put your left hand up. It looks like a mirror. When you put your left hand up, it goes like this way. So your left hand, when you open it up towards you like this, would be less than. It looks weird because I'm mirrored. But okay, just put your left hand up and do like this, and that's the less than symbol. Okay. Okay. So this is also a less than symbol, but is less than or equal to. So the underline makes it an equality type of deal going on. So the opposite way is going to be greater than, and with the underline is greater than or equal to. So just make sure that you just make sure you know the distinction. You will notice is greater than and or equal to is both. All right, so got the terminology out of the way, and you're gonna see once we dig in, it's gonna be much more apparent. Okay, so over here, this is saying we have -9 and 8, and it's contained within those two inequalities. So what you do to express this in set builder notation, I like to graph it first. That's just me. I think it makes it much more simple to look at. We're gonna have -9 over here somewhere, right? So most people like to put 0 for starters. Just put a 0 there, just so you know that that's the middle. We have -9 somewhere sitting over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There is our -9 sitting right there. And on the right side, we have +8. 1, 2, 3, 4, 5, 6, 7, 8. So +8 is here. And now with respect to the symbols that we have there, you can go ahead and put a parentheses right here. And on the right side, because we have a bracket, we have a equality symbol, we can put that on the right, going in the same direction. So if you have one written this way, you're going to write this the same that way. And it's the same thing with the parentheses on the left. Just write it just like that. And now we basically just shade right in between. Let's do a different color. And you shade right in between, and that's going to be our graph. So, how do we put this in set builder notation? Well, set builder notation uses the alligator mouths. You want to know how to read this. So let's start here from the left. We always go from left to right, just like how we would read a sentence. All right, so if all of this is x right here, this is all describing x, right? That's the variable that they use. How does x compare to -9? And then how does x compare to 8? X is in between -9 and 8, right? So if you're going to use set builder notation, you start by writing your variable. And you're going to put your two alligator mouths going in that direction. Make sure they're both going, make sure they're opening up to the right. And you go ahead and put the numbers on the outside that are on the ends. So we have -9, we have 8. And now you have to ask yourself, am I using an equal to symbol or am I not? So on the left side, that's a parentheses. So a parentheses does not include equality, but the right side does because it's a bracket. So all you do is underline that. And that's it. So for our solution, this symbol right here stands for x such that, you know, it has like the little vertical line, x such that x is in between -9 and 8, with the equality symbol being on the 8. So go ahead and type in your -9, just like you have it here. Put your alligator symbol that does not have the equal to. Put your X. You have to make sure you use the same variable. We're going to have another alligator mouth and an inequality symbol. That's what they used to call them back in the day, alligator mouths. Nice work. Okay, now the graph. The graph should look exactly like our graph. We should have a parentheses around the 9 on the left. There's one. These don't have parentheses, right? There's our parentheses with the -9, and then we're going to keep on going until we see the bracket around the 8. Do we have a bracket, a square bracket around the 8? Yes, we do. So it has to be this one. All right, so far so good. Let's take those foundations that we established and just go from here. See, I already did this one. You see, X is going to be in between -7 and -4. So you go ahead and put your X in the middle. Make sure you put your bracket right there. So yeah, that's going to be the answer for this one. As for the graph, X should be in between -7 and -4. There should be a bracket around -7. So even though you don't see the -7 written down, you know -7 is in between -8 and -6, right? We have a bracket there. That could possibly be it. Do we have another bracket around the 7 here? Yes, we have another bracket around the -7 here as well. Let's make sure the right-hand sides are correct. So on the right-hand side, we have less than -4, and there should be a parentheses there. So over here, we don't have a parentheses at the -4, but we do here, and that's why this is the answer. So we have plenty of practice. I think there are 30 questions on this one. Let's just keep on going. And over here, we have X is in between -1 and 2. So this is the set builder notation. Put your X in the middle. Just like in our example, we always put the X in the middle, and we make sure we use the appropriate symbols. We have 2 brackets here, 2 square brackets, so we need 2 equality signs, 2 inequality signs that are equal. Okay, and go ahead and put your numbers on the left, put your number on the right, reflecting this, and that's it. Make sure your graph adds up. Yep, this is it. -1 and 2 is in between. Shade everything, bracket, bracket, and it's pretty consistent. Okay, looks like made a mistake and got this one wrong. We're going to hit similar. Okay, so now we have the concept of infinity. You know what infinity means. Infinity means it goes on forever and ever. So how do we express this? Well, you start off by making a graph, you know, the tried and true graph. You can put 0 if you want, it doesn't matter. But we definitely need to put our 2. So you know it goes on forever and ever. We'll put the numbers in. Okay, so first and foremost, you want to go ahead and start at whatever this guy is right here. You go from left to right. It starts at 2, so go ahead and put your 2. And we're going to put the same symbol that's surrounding that 2, the parentheses, going in the same direction as this guy right here. So, how do we read this? This is going from 2 all the way to infinity. Where is infinity? Infinity is all the way to your right. It's 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 million, bazillion, jillion. So we're just basically going to shade everything over here to the right. And that's infinity. So as for the set builder notation, X is going to be all the numbers that are greater than 2, but not equal to 2, right? So is X such that X is greater than 2? That's it. From 2 to infinity. So let's go over here and put X is greater than 2. All right, well done. And now, whichever one closely resembles our graph is the right one, and that's sticking out like a sore thumb right there. Good job. That's it. So with infinity, just keep on shading until you can't shade anymore. Okay, let's do this one. So we have -5 to infinity. All right, first things first, graph it up. Let's put our -5 here in the middle. I know we normally put 0, but you want to break out of habits. You want to use what's most convenient to you. How do we read this thing? From the left, we have a bracket around the -5. So let's go ahead and put a bracket around -5. And then it's going to go all the way to infinity. Another thing of note, you will never see a bracket around infinity. No, that is not possible because a bracket implies equality, and you cannot have anything equal to infinity. Like, it just doesn't make any sense. Like, infinity is one of those things that it has no bounds. So if you want to be a good little mathematician, never put equals infinity for the level that we're at now, or ever for that matter. All right, anyway, so this is -5 going all the way to infinity. So just make sure you shade everything to the right. And that's it. That's it for the graph. So we're going to get that if they ask us. Set builder notation. X is greater than -5 because it's going to the right-hand side. So X has to be greater than or equal to -5 because it's going to the right. It's greater than because it's positive infinity. So go ahead and put your X, put your greater than or equal to, and put your -5 right there. And bam, excellent. Now the graph that closely resembles our graph with a bracket from the left, from this guy over here, is right there, going all the way to infinity. Nice work. Okay, moving right along. We have -infinity. Now we have -infinity. It's just like positive infinity, but over to the other side, the left side. I don't want to point because I think my screen is mirrored. But anyway. Go ahead and put your key player down, your 1. Yeah, infinity would be, -infinity would be that way. Even though it's opposite for me. But for you guys, it's -infinity is that way. All right, let's go ahead. So the symbol that's surrounding the number, your key player, which is 1. -infinity is always to your left. So you know what? Let's go ahead and write -infinity and positive infinity so we know where they're at. All right, so -infinity would be to your left. So go ahead and shade all the way to your left. And remember, you don't want to close it up. You don't want to put a parentheses here. Even though there's a parentheses up here surrounding this -infinity, you don't want to put it like that. It's a little, it gives you the impression that it's contained somehow. But remember, this arrow right here, this is going to keep on going. But, we're basically done. And you want to be able to read this. What is X compared to 1? Looks like we went all the way to -infinity, so X will have to be less than 1. X could be -2, -3, -4, -5, -1 million. X compared to this one right here has to be less than it. So X has to be less than 1. Now, I know a lot of people tend to confuse the less than and the greater than symbol. With respect to X, they call this an alligator mouth for a reason. So let's imagine some teeth here. X is less than 1, right? The alligator, think of an alligator. We're in Florida. Well, I'm in Florida. An alligator is a greedy animal. It's gonna, I mean, don't get me wrong. It will get what it can get, but if it had the choice, it would choose the larger option, the greater option. So over here, the alligator is not eating X. So X cannot be greater than 1. X has to be less than 1. So 1 is greater than X, so X is less than 1. So whenever you're trying to figure out how to say it with respect to the X. Say X is blankly blank blank blank. You never want to start off with the number. Even though technically it's correct, 1 is greater than X, but I want you to get into the habit of saying X is whatever. So in this case, X is less than 1 because the alligator is not eating it. So let's go ahead and put that here. I learned this in 3rd grade, and it's never left me. Like, that teacher, shout out to Miss Smith from Dillard Elementary. Bam. Okay, so which one closely resembles our graph? Has to be here. Well done. Ah, the union stuff. And this is not union. This is the word for and. And you're going to see how it works out. So, what is all this about? But basically, it takes two inequalities, right? So remember, we've done -6 to 8. We've done something similar to that. And you're going to see once we put it on our number line, how it all ties together. But this sign right here stands for and. And basically, remember we were shading both sides. Basically, the and only wants where the shades actually touch each other, as opposed to or, which we're definitely going to see later. Definitely going to see later. The or is wherever you have a shade. So you're going to see we're going to do a lot of examples. There's a lot of examples here. We're on question 7. We have like 30. Let's go ahead and do this. So let's put our key players down. You can put your 0 in the middle if it helps you. We have a 9, we have an 8, we have a -6, we have a -2. Let's do it this way. Let's put -6 here. You don't have to really scale it off, just as long as you know where the numbers are. We have -2 right here, and then we have 8, and then 9 would be somewhere over here to the right. So we have all of our key players, and we have to make sure that we put the appropriate shades down and the appropriate symbols. So right now, I'm going to go ahead and make the appropriate symbol for this first inequality here, -6 to 8. So let's put the parentheses. And we're going to shade all the way down until we reach 8. And we're going to make a closed parentheses like that because it's using a parentheses. All right, same thing with the other one. We're going to go ahead. Should I choose a different color? Yeah, we'll choose a different color. We'll choose this lime green here. Now we're going to start off at -2 with an open bracket, same direction as this one. And we're going to shade all the way until we reach 9. You see I'm going over that other parentheses, and we're going to use the same symbol bracket. Now, taking a look at what we have here, because we're dealing with and, very important, you only want to include where those two lines intersect. So you see right from here and here, those lines are like right on top of each other. You want to go ahead and make a double shade like that. Just get it, just to express that, hey, these two things are touching right from here to here. You know what? Let's mark it in red to make it more apparent. So right here and here is where you see both lines meeting each other, right? And where are they meeting in terms of the numbers? What numbers are they meeting at? They're meeting from -2 all the way to +8. And that is our solution. That is our interval notation. So between here and here is our solution. We have a bracket. So whatever symbol's there, that's the same symbol you're going to use here. That's a bracket from -2 all the way to +8. This is a parentheses, so put your parentheses and we are done. Let's go ahead and put an open bracket. Where's my bracket? Oh, here it is. My keyboard, if you were to see my keyboard, they look almost exactly alike. They're not making it square enough. All right, so we have -2 and we have +8. Close it up. What did I do? Type your answer into notation. We have -2, +8. What did I do wrong? Oh, parentheses. Haha. It's funny. Yeah, this keyboard, if you were to, yeah. All right, nice work. All right, moving right along. All right, we have another, now this is a union. So with the intersection, with the and symbol, the upside down U, we only put where the shades overlap. But with the union, you include wherever there's a shade, and that stands for or. So we have open parentheses -1 to 7 union with, sorry, that's not a parentheses, this is going to be a bracket, 0 to 9 and bracket. Okay, so let's go ahead and just jump right in. Start by making your little line here. Yeah, we actually have a 0, so how about we use 0? Let's put little arrows here to show that it's going off to infinity. Okay, put your key players down. We have 0, we have 9, we have 7. So wouldn't 7 be here and then 9 follows it? And over here, we're missing -1. Let's put -1 here. And we have all 4 of our numbers, 1, 2, 3, 4, 1, 2, 3, 4. Yep, that's all of our key players. All right, so let's go ahead and start shading. So let's do the first one. We have -1 to 7. So there's a parentheses at -1. Let's go from -1, and we're going to shade all the way up to 7. And that is also a parentheses like that. And we're going to do the same thing with the 0 to 9 interval. Let's use a different color. So from 0, we have a square bracket going in that direction, same as this. And we're going to shade, keep on going. Don't stop at the 7. Shade all the way until you get to +9. Now we're almost done. The union, because now we're dealing with OR. This stands for OR and union. The union is wherever you see a shade. So last time we only focused on this guy right here, because that's where they both intersect, right, between here and here. But now, because of union, you're going to include wherever you have a shade. So that's everything from here all the way to that 9. So we'll just do it like that. So it's everything in between -1, +9, and that is your union. So this is between -1 and +9. Make sure you put the appropriate symbols. That uses a bracket, so this uses a bracket as well. And that's it. So this is -1, and this is +9. Nice work. See, not so bad, right? All right, we have an OR. I'm sorry, we have an intersection. Intersection, just like the intersections that we know in real life, is wherever they meet, wherever they touch. So let's go ahead and make quick work of this. We have -infinity to -1, intersecting with -6, 3 close parentheses like that. All right, let's go ahead and make our number line. Put your key players down. We have a -infinity this time, which is going to be way over there to the left. We have -6. Then we have -1. Then we have 3. We can put 0. Why not? Then we have 3. Okay. So let's go ahead and put the appropriate shadings. So -infinity to -1. So we have a parentheses around -1. And we're going to shade all the way to -infinity, going in that direction. Over here, let's go ahead and do -6 to 3. So we have -6 here with a bracket. And we're going to keep shading in that direction until we reach +3 with the parentheses. Now, this is intersection, this is and. So where do they meet? We're only going to include where the two shades overlap, and that's between here and here, right? We have one line on top of the other. Okay, so that's our solution. So we're going to use -6 and all the way to -1. I know this looks pretty ugly, so let me redraw what I'm saying. If you ever have an intersection and they ask you to sketch it, go ahead and put where that intersection occurs. This occurs at -6 and -1. So you can just go ahead and put a bracket here, just shade in between, and over here, parentheses. So this is basically what that up there is. This is the real deal. We're done. So go ahead and copy and paste this intersection. It starts at -6 and it goes to -1 with the parentheses, and that's it. Well done. Tired yet? Let's not do red. I like orange. All right, so we have -infinity going to 0, union with -6 all the way to 3. Yep, same deal. Let's go ahead and make a little number line. We have -infinity, which is going to be all the way over here to your left. What else we have? We have -6 We have 0 and we have 3. Let's go ahead and start shading. So from negative infinity to 0, I like to start at the number first, and we're going to shade all the way to negative infinity. So it's going to keep on going. What about negative 6 to 3? So this is negative 6 all the way to 3, going in that direction. Close parentheses. This is a union, so your answer is wherever you have a shade, period. Okay, so we have a shade starting all as far as here. So let's go ahead and mark that as red. We're going to keep on going, keep on going, keep on going. We're still going to keep on going because we have some shaded region here, and we also have shaded region here as well. So that sucker is going to go all the way to negative infinity, all the way from here to here. So let's go ahead and copy and paste what we have in red. This is from negative infinity all the way to 3. So you always put a parentheses at your infinity symbols, whether it's positive or negative. Never put a bracket. So this is negative infinity all the way to 3 with the parentheses, and that's it. So aren't these fun? So negative infinity all the way to 3. Nice work. All right. Let's keep on going. Yeah, I can do this all day. All right. We have negative 7 all the way to positive infinity, and then we have, okay, let's go ahead and do it. Okay, I hope you guys can't hear that. There's someone cutting the yard. Okay, you know what's coming up. We're gonna graph. We have we have 2 positive infinities here. Let's go ahead and put a positive infinity right here. We have negative 7 somewhere over here, and we have a 0 here, right? So, let's go ahead and start shading. So we have negative 7 to infinity. So that's going to have a bracket, and it's going to go all the way to infinity, just like that. And we also have 0 to infinity. Let's put that as lime. It's going to have a parentheses, and it's also going to be going all the way over here to the right. So we're dealing with union, which stands for and. And basically our answer is only where we have 2 lines, double lines. So where do we have double lines? Well, it starts off from here, right? Right at this point, that's where we have 2 lines, and it's going to shoot all the way to infinity. So let's reflect that in our interval notation. So the new line looks like this, the new graph. I know I haven't really been doing that often, but it goes from 0 to infinity. It's going to look something like that. Here's positive infinity. Okay, so copy and paste this new graph so that we have an interval notation. And that's it, from 0 to infinity with parentheses. All right, good job. All right, keep going. All right, open bracket, negative 3 to infinity. I'm going to go ahead and pick up the speed. I think you guys have the idea now. All right, go ahead and make a graph. We have infinity over here. We have negative 3 over here. We have 1 right here. All right, let's go ahead and start graphing. So this is negative 3 to infinity with a bracket. This is 1 to infinity with a parentheses. We want the union, and as you know, the union includes any and all shades. So we have some shaded region here. Let's go ahead and fill that in with red. We have all that. It's going to keep on going, and that's it. So this is negative 3 to infinity. So negative 3 to infinity with a bracket. Well done. Okay, now we have an inequality. And all right, that was a nice little section. That was good practice, right? Now we're going to do some things that are more algebraic in nature. So let's go ahead and do 2x plus 4 is greater than 7. All right, you're going to see as we go, negatives are the most trickiest parts of these when you're multiplying and dividing by a negative. You're going to see what I mean in a little while. Anyway, let's go ahead and solve for x as if this is an equal sign. Yeah, we do it the same way. Subtract 4 from both sides. We're going to go ahead and get 2x is greater than 6, right? Nothing crazy so far. Go ahead and divide both sides by 2. You get x is actually greater than 3. So they're asking us for the solution set. It says, other than a no solution set, use interval notation to express the solution and then graph. Okay, so this is telling me that x is greater than 3. So you can make a little graph like this, put your 3 down. X is greater than 3 will have to go all the way in this direction. Somewhere like that. And what symbol do we use? This is not an equal to, this is greater than, so we're going to use a parentheses like this. And this is basically 3 to infinity. And that's it. 3 going to infinity. Well done. Okay, so which one mostly resembles our line? Let's put it in red so you can see it easier. It goes from here all the way to here. So it starts at 3, goes to infinity. Looks like that's our guy. All right, nice work. That's it. Okay. We have 3 x minus 4 is greater than or equal to 23. Sweat. All right. All right, so we're going to go ahead and add the 4. We get 3x is greater than or equal to 27. Go ahead and divide both sides by 3. Why do I always do that? Something's wrong. My writing pad is a little weird. It just makes me want to, I don't know. X is greater than or equal to 9. Go ahead and make your little graph. Put your key player down. X is greater than or equal to 9. So that's in this direction all the way to infinity. So this is 9 to infinity. And why did I make my infinity like that? There we go. That's more like it. And always put a parentheses at infinity, not a bracket. So this is 9 going all the way to infinity. Well done. Okay, so which one closely resembles our graph? That's right here with the bracket, of course. All right, well done. All right, we're almost halfway there. We're already at 15. Okay, here's where the fun starts. The magic. They threw a negative in there. Okay, so we have negative 6x is greater than or equal to 48. So let's go ahead and get rid of the negative 6 by dividing by negative 6. Because this is multiplication. To get rid of multiplication, you divide. Don't be tempted to add positive 6. You can't add to a multiplication problem. This is negative 6 times x, so the only way you can get rid of multiplication is by dividing. So anyway, we divide by negative 6, we're going to get x. But now with the nature of inequalities, whenever you multiply both sides by any negative number, period, or multiply by a negative number, you're going to flip the algorithm out to the other side. Commit that to memory. You have to make sure that you get that. It's very important that you do. You never want to just keep this symbol where it's at. If you ever divide or multiply by a negative number, flip it around. Okay, can you remember that? If you can remember, you will be victorious. Let's read this. X is less than negative 8. So we're going to shade this way, and we're going to use a bracket because of the inequality, the equal sign underneath, and that's it. And let's not forget our negative infinity. So the solution set, interval notation. So we're going to have a parentheses, negative infinity, and then -8 has a bracket around it, right? Just copy and paste. So this is negative infinity, comma, -8, bracket. I swear these things like just, hopefully your computer's keyboard print doesn't look like these symbols look exactly alike. Don't mind me. Okay, so negative infinity to -8, which one closely resembles our graph? Right over here. All right. All right, there we go. Okay. 9x minus 8 is less than or equal to 2x minus 13. So we have x's on both sides. Let's go ahead and combine those x's by bringing this 2x over here. And while we're at it, let's add the x to both sides to get rid of this. I'm sorry, add the 8 to both sides to get rid of the 8. That goes away, that goes away. So we have 9x minus 2x is 7x, less than or equal to -13 plus 8 is going to give you a -5. Go ahead and divide both sides by 7. And this is x is less than or equal to -5 over 7. Where is -5 over 7 on our number line? Maybe they'll have us do it, maybe they won't. We know 0's in the middle, and every negative value is to the left of 0, so we should have something like this. So you remember that 5 over 7 is less than 1. So let's put a positive 5 over 7 just so I can give you some perspective. 5 sevenths, isn't that less than 1? 7 over 7 is 1, but when we have 5 over 7, it's just 2 more shy in the numerator to make it to a whole number. So it's the same thing over here. This is going to be -1, so it should be right before you reach the -1. And let's read our inequality. X is less than or equal to -5 over 7. Here's -5 over 7. We have the equal to is less than, so it's going to shoot that way towards -infinity. And that's it. So this is -infinity all the way up to -5 over 7. Okay, what did I do wrong? Let me see. X is less than solution set in interval notation. Let's see, 2x is 13, 9, it's -5 over 7. Damn, these symbols look alike on this keyboard. and then it didn't help that I messed myself up as well. Okay, this is a square bracket. Let's go ahead and delete that. Man. Anyway, square bracket. Square bracket. I don't think you're gonna have this problem. I'm a little messed up, but this keyboard is messing me up today. All right. Let's go ahead and keep going. Oh, continue. Okay, let's see. We already have the graph. This is -infinity all the way to -5 over 7. You can see it in red over there. This has to be it, right? Remember I told you that is right before you reach the -1 going to the left. So -5 over 7 will have to be like somewhere right here. And it has the bracket, the square bracket, and that's it. All right, next. Okay, so 5, open parentheses, x plus 1 plus 4. Then we have 4x plus 12. Let's do some good old-fashioned algebra. Go ahead and start by distributing this 5 to the x and the 1. So we have 5x plus 5 plus 4 is greater than or equal to 4x plus 12. Let's combine like terms. We have 5 plus 4 on the left-hand side. We have 5x plus 9 is less than or equal to 4x plus 12. Let's start moving some things over. Let's bring this 4x over by subtracting it. And let's go ahead and bring that 9 to the right by subtracting that. So we have the x's on the left, the numbers on the right. So we have 5x minus 4x is x, greater than or equal to 12 minus 9 is 3. So we have x is greater than or equal to 3. We can graph it up. Graph it up. We have 3. X is greater than 3. So it goes to infinity. And what symbol we're going to use? We're going to use the bracket because of the equal to. We should be good. Paying attention this time. I'm going to use the square bracket. So the solution, oh, we never wrote the solution down. So copy and paste what you got from the graph. This is from 3 all the way to infinity. All right, so this is 3 all the way to infinity. Fantastic. Okay, so this is 3 to infinity. Which one closer resembles? Hey, I noticed something. They're changing up the notation just a little bit, and I'll show you what I mean. Now, so far we've been using this this bracket here, right? But did you know that if depending on whether you have a parentheses or a bracket, did you know that instead of using a parentheses, you can use an open circle? And instead of using the bracket, you can use a closed circle. So they mean the same thing. It's very subtle how they just spun it up on us. It's okay. We'll play by the rules. Instead of using a bracket here, we'll use let's make it a little bit more apparent. We'll use a closed circle and do the same as that thing. Send it in that direction with that closed circle. So it's not the end of the world. It looks like that's our answer right there. All right, fantastic. All right, next, moving right along. We're on number 18. We're making good progress. We have 5 minus 2x. Then we have 25 minus 3x. So 4 times 5 is 20. We're just distributing. 4 times negative 2x is negative 8x. Greater than 25 minus 3x. So let's go ahead and start moving some stuff over. Yeah, it's time. So we're going to subtract the 20 from both sides. And we're going to add 3x to both sides so we can bring the x's over. So we have negative 8 plus 3 is negative 5x. Greater than 25 minus 20 is 5. Go ahead and divide both sides by negative 5. You know what's coming up next. We're dividing by a negative. Flip that alligator around. Put your negative 1. Call it a wrap. X is less than negative 1. So we have negative 1 here. Less than would be somewhere over to the left for less than. And this is going all the way to infinity. And the symbol we're going to use, let's see if it's going to be a parentheses because it's not equal to. Let's see if they use the open circle notation like they did last time. All right, so let's copy and paste our solution. This is negative infinity all the way to negative 1 with the parentheses. Yeah, we're going to be ready this time. Interval notation is what we got down here with the parentheses stuff. So that's negative infinity to negative 1. And which one reflects it? This time they use the parentheses this time. Whatever. They just switch it up on us like that. We'll use the parentheses as well. Whatever. Same thing, tomato, tomato. At number 19. They're just trying to make it more and more difficult, right? Such as math. 6, we have 2x minus 4 minus 8x less than 2, parentheses 3, plus 2x, then minus 15. What a doozy. All right, go ahead and distribute. We have 12x minus 24 minus 8x less than 6 plus 4x minus 15. Once again, I'm distributing. Combining like terms, we have 12x minus 8x, which is 4x. We have minus 24 less than, combine like terms, let's put 4x first. 6 minus 15, it's going to give you a negative 9. All right, let's subtract 4x from both sides. Take a look. We have negative 24 is less than negative 29. Is this a true statement? Is negative 24 less than negative 29? Yes. If you were comparing positive 9 and 24 for a second, which one is bigger? Definitely the 24 is larger, right? When they're both positive, we know that. We know 24 will always be 9. However, when they're both negative, you have to flip your judgment and say that negative 9 is greater than negative 24. And that is a true statement. So if you ever come up with an inequality and your x's cancel and it ends up being a true statement, the answer has to be all real numbers. So this is from negative infinity all the way to positive infinity. Basically, no matter what you plug in for x, the left-hand side is going to always be less than the right-hand side. So basically, you want to make sure that your any statement is true or not. Let's go ahead and put negative infinity all the way to positive infinity. And that's it. Nice work. Okay, so the graph, the way the graph looks, the graph looks like this. Everything is shaded. Let's use blue. Everything is shaded from here all the way to here. It's the whole enchilada. Everything is shaded. So it looks like that's going to be B. Well done. Okay, so we just did our first all real numbers solution. Okay. All right, we have an and problem. So you remember the and stuff. Remember and we were using this symbol. Yeah, we were using this symbol before. So remember that means and, this means or, and you're basically going to go ahead and put all of your shaded region as your solution. Let's go ahead and do this. So we have x minus 3 less than or equal to 3, and we have x plus 1 is greater than or equal to 4. So separately, let's go ahead and solve for these. We have negative 3 here, so we're going to cancel by adding. So we have x is less than or equal to 6, and go ahead and subtract the 1. Subtract the 1. We have x is greater than or equal to 3. So we have one of those compound inequalities again. That's what they call these. Start by making your graph. We always go to the graph. Put your key players down. 3 and 6. Let's read this one at a time and just shade according to what we see. So x is less than or equal to 6. So we have a bracket, and less than is going in that direction. Always. Next, we have x is greater than or equal to 3. So we're going to have another bracket. Let's use line. We're going to have another bracket. And it's greater than, so it shoots in that direction. Now, this is an and problem. So we only include where they both meet, where the two shaded regions meet, the intersection. And where is that? That is between positive 3 and 6. So 3 and 6, both with brackets. So any number you plug in, including 3 and 6, would make this equation true. So 3, 6. I kept a parentheses there. You heard me hit that delete button. But anyway, this is between 3 and 6 inclusive with the equality symbols with the brackets. Nice work. Okay, let's keep going. We have negative 4x is greater than 8, and x plus 7 is greater than 0. Okay, so, let's go ahead and just solve. Okay, so divide both sides by negative 4. We're going to get x. You just divide it by negative. Flip that sucker around. This is going to be negative 2. All right, and over here, go ahead and subtract the 7 from both sides. We get x is greater than negative 7. Go ahead and make your two graphs on one line. Negative 7 is over here somewhere. Negative 2 is over here somewhere. Now we're going to start shading. So x is less than negative 2. Let's go ahead and put your parentheses and shade in this direction. X is greater than negative 7. We're going to put a parentheses here at negative 7 and shade in the opposite direction. This is and, so we only want where they intersect right in between here and here. And we are done. Same symbol. So this is negative 7 all the way to negative 2. And we're done. Okay, so between negative 7 and 2, non-inclusive. That's this guy over here. Good job. Solve the compound inequality. Graph the solution set. All right, let's do it. 2x minus 5 greater than negative 13. And negative 6x plus 5 less than negative 31. Okay, let's go ahead and solve. So plus 5, we're going to get 2x is greater than negative 8. Divide both sides by 2. We're going to get x is greater than negative 4. Over here, subtract 5 from both sides. We get negative 6x is less than negative 36. Divide both sides by negative 6, which means we're going to flip this alligator mouth the other way. We get x is greater than 6. So make your little graph. You see, this is just repetition, right? As soon as you solve these things, the more you do them, it'll be like second nature to you. Make sure you don't have a keyboard that have the brackets and the parentheses looking identical. Trips me up. All right, anyway. X is greater than negative 4. Go ahead and put your parentheses and shade greater than negative 4. X is also greater than 6. Put another parentheses and shade greater than 6. They're both going in that direction. This is an and problem, so you want where they both intersect. They start to intersect right here from 6 on out. So this is from 6 all the way to infinity. That's our solution. With the parentheses, yes. All right. All right, we have an OR problem. So we have x is greater than or equal to negative 5, or x is greater than or equal to 6. They didn't make us do anything. Okay, I'll take it. We'll take it. We eat those. All right, so we're going to put our key players on negative 5, positive 6. X is greater than negative 5. So with the bracket, so x is greater than this guy over here. Keep going all the way that way. And x is also x is greater than 6 as well. So we're going to put a bracket here and we're going to shade that way. This is an OR problem. So wherever you have a shade, period, whether they're touching or not, you're going to want to include that in your final answer because we have or. It's either or. So we're going to shade this blue line. We don't have to retrace this inequality because it's included because of the lines. So that's it. It's going to go all the way from -5 all the way to positive infinity. Fantastic. So from -5 to infinity, that looks like right here. Good job. I hope you guys don't hear that. Somebody's working on the yard, like right next to my freaking window. X is greater than -5, or X is less than or equal to 4. Easy. Easy peasy. I'm not complaining. -5. We have 4. Okay, X is greater than -5, so put a parentheses and shade over to the right. X is less than positive 4, so make a bracket. We're going less than, so we face that way and keep going. This is an or problem, so wherever you have a shaded region, that's where you want to include your answer. So we have a shaded region everywhere, all the way here from negative infinity all the way to positive infinity. Everything is shaded, everything has been touched. So you know what? This is negative infinity to positive infinity. So this is all real numbers essentially. So let's put negative infinity right here. And we have positive infinity, close it up. And everything should be shaded. So this is E. All right, 25. Okay, we have X plus 1 is greater than 4, or 5 minus X is greater than 6. Go ahead and subtract 1, X is greater than 3, or let's minus 5 from both sides. We get negative X is greater than 1. We didn't come all this way for a negative X, so let's divide both sides by -1, or multiply both sides by -1, whatever floats your boat. We just divided by -1 though, so we flip that around and we get -1. So we have X is greater than 3, or X is less than -1. All right, let's graph it up. Put your key players down, -1, +3. X is greater than 3 with a parentheses. X is less than -1 with parentheses as well. It's less than, so it goes that way. This is an or problem, so wherever you have a shade, that's what we have to include. So mind you, this is negative infinity when it goes that way forever, and this is positive infinity. So just be very careful with this. This is the first time I think this is the first time we have one of these going in opposite directions like that. Because this is an or problem, you include wherever you have a shade. So this is going to be from negative infinity coming from here. It's going to stop at -1 with the parentheses. And now because you have a space in between, you want to put the union symbol. Union with is going to pick right back up at 3 all the way to infinity. So I want to stress again that whenever there's a space in between, like a gap or a jump or space, you want to put a U to keep them in union. And that's it. So negative infinity, comma -1. Union with, so here's the U symbol that you're going to use. Then we have 3 all the way to infinity. Well done. Okay, so which one closely resembles our graph? We have two parentheses, so it's that one. Okay, let's do this. All right, we have 3x minus 7 greater than negative 25, or 6x plus 7 greater than 19, greater than or equal to 19, less than or equal to 19. Sorry. All right, let's solve. Add 7, 3x is greater than or equal, greater than 18, negative 18. Over here, we're going to subtract 7. Oh, let's finish this. Let me not jump the gun. X is greater than or equal to 6. I keep saying equal to, darn it. X is greater than negative 6. Over here, minus 7, 6x is less than or equal to 12. So x is less than or equal to 2. All right, put your little number line. Put your key players down. X is greater than negative 6. So we're going to go in that direction. X is less than 2 with that bracket. So we're going to go in this direction. Once again, it's wherever you have a shaded region, everything is shaded, looks like. So this has to be all real numbers. All right, good job. Shade everything. There we go. All right, I think we have 4 more problems left. Take a look at this one. We have 5 is in between. We have a compound inequality. Let's look at it this way. You can imagine if this is if we have 3 sides. It's kind of weird to say it that way, but you'll get what I'm saying. All right, so you know how we get the x by itself? We get rid of the 7. Here's what I'm proposing. Let's subtract 7 from all 3 sides. Why not? So you get negative 2. You get your x, because those cancel, and you get 2. Look at that. We have a nice little compound inequality going on, and I will show you how to read this. You probably already have an idea. Let's put 0. Let's put your key players down. Negative 2, positive 2. X is greater than negative 2. X is also less than 2. Yeah, let's go step by step. X is less than 2, right? So from the 2, and let's spice it up a little bit. Let's use some open circles here. X is less than 2, so we're going to shade from the left of 2 and go that way. X, negative 2, if you read from left to right, negative 2 is less than x. So read it in reverse. That means that x is greater than negative 2. So if it's greater than negative 2, it's going this way. So that's it. That's our graph. If you like, you can put this is in between negative 2 and 2. And so far, this is the easier form of the compound inequality. So you know they're going to give us something a little bit more difficult. But hey, we're done. What more can they ask for? This is from negative 2 all the way to 2. Well done. Okay. It's the same deal, same routine. We have negative 3 is less than or equal to x minus 1 greater than 6. All right, let's go ahead and add 1 to both sides. So we have x, we have 7, and we have negative 2. And this looks pretty straightforward. We're going to go ahead and make our number line. We have negative 2, we have 7. Let's read it step by step. Negative 2 is less than or equal to x. So therefore, x is greater than or equal to negative 2. You see how I switch it up? When you go from left to right, you know this symbol means less than. That symbol means greater than. If you just read it from left to right, you can't go wrong. But try to get into the habit of switching that up too. So negative 2 is less than or equal to x. So therefore, x is greater than or equal to negative 2. So if it's greater than or equal to negative 2, it's going to look like this. X is less than 7. So x is less than 7 is going to go something like that. And this is basically, it's just like a union problem. It's wherever you see both of them overlapping, and that's in between here and here. So between negative 2 and 7. And we're done. So negative 2, 7. Nice work. Oh, they didn't want a graph. That's good. It's fine with me. All right, so we have negative 2 less than 3x minus 2 greater than or equal to 7. All right, so we have 3 sides. Let's go ahead and add 2 to all 3 sides so we can get rid of the 2 in the middle. We have 0 is less than 3x less than or equal to 9. Now, to get rid of this 3 in the middle, let's divide everything by 3. So we have 0 is less than x less than or equal to 3. We're done. We have our 0. We have our 3, which is over here somewhere. 0 is less than x, so therefore x is greater than 0. So let's shade everything greater than 0. X is less than 3. So let's put a bracket here. And let's put less than 3 going that way. Where do the 2 shades overlap? They overlap right up in here between 0 all the way to 3. So this is going to go from 0 to 3 with a bracket. So 0 all the way to 3 with the bracket. Notice I'm not messing up anymore, right? Like in my brain, it's like I don't want to mess up anymore with the bracket stuff. So my keyboard's already messing me up, and it takes one little distraction to really throw you off your game, right? All right, but never again for a while. Okay, so 7 is less than or equal to 1 over 2. We have x plus 6 and less than 9. Okay, so let's go ahead and subtract 6 from all 3 sides. You get 1 is less than or equal to 1 over 2x less than 3. Now, this is 1 half x is in between. I would like to get rid of that 2 that's underneath. When you have 1 half x, isn't that basically x divided by 2? So to get rid of a division, don't we multiply? So to get rid of a 1 half, we're going to multiply by 2 because 2 halves make a whole, right? So just multiply each and everything by 2, and that should get rid of the 1 half. And it does. 2 times 1 over 2, the 2's cancel. You're just left with x. Over here we have a 6, and over here we have a 2. So x is in between 2 and 6. Let's put our 2 here. Let's put our 6 here. 2 is less than or equal to x, so x is greater than or equal to 2. So let's put greater than or equal to 2. Shade all the way to infinity. We have x is less than 6, so let's put a parentheses there. I almost made a bracket. Let's put a parentheses here and put less than 6 going all the way in that direction. Where do the 2 meet? The 2 meet right up in here from positive 2 all the way to 6. Let's put the appropriate symbols. This is 2 to 6. And we are done. And it looks like this is the last question of this section. So if you made it this far, thank you very much for watching. This is really going to help out my channel. View this so you can get a good grade on your quiz and also to complete your homework. Thank you so much for watching. Take care.